List potential rational zeros. These are only the ones that would make my list. What do? The coefficient of the front is 2. And I can ignore the sign. The coefficient of the back, or the constant in the back, is 6. I look for the divisors of this is this guy right here. P is the back, and Q is the front. So what divides the back? What divides 6 evenly? And you take both plus or minus. And 1 divides it evenly, so plus or minus 1. 2 divides it evenly, plus or minus 2. 3 divides 6 evenly, plus or minus 6. 6 divides 6 evenly, or plus or minus 3, plus or minus 6. What divides the front of the bus? It's a 2. 1 divides 2, because 1 divides everybody, so plus or minus 1. 2 divides 2, plus or minus 2. Now you're going to take the factors of the back divided by the factors of the front, alphabetical order. The factors of the back are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Of the front is just plus or minus 1, plus or minus 2. So what do? I take the first divisor, divide plus or minus 1 into everything. What would I get? 1, 2, 3, and 6, just itself. Then you take plus or minus 2 divided into, I'd get plus or minus 2 divided into plus or minus 1. That's where the plus or minus 1/2 comes from. Plus or minus 2 divided into plus or minus 2, that gives you plus or minus 1, already in my list. Plus or minus 2 into plus or minus 3 gives you plus or minus 3/2, so you add that to your list. Plus or minus 2 into plus or minus 6 gives you plus or minus 3, already in the list. Now, these are your possible rational zeros. What's the degree of this guy? He's degree 3. What's the maximum number of zeros?
3.
The maximum number of zeros is 3. How many possibilities do I have? 2, 4, 6, 8, 10, 12. If they're all rational, I only need 3 of those 12. Now, if you, depending upon what class you're in, and if you're in a more traditional algebra class, then you would use Descartes' rule of signs to narrow the list down to get the positives and negatives. Then you would use the upper and lower bound rule to get what is the maximum of your and minimum of the list, and so that throws some other ones out. And then you start checking these suckers individually. Well, that's a pain. We don't want to do that. Too much work. Okay, so now we're going to be like Santa, and now we're going to make our list. The front of the bus is a 2. The back of the bus is a 1. So if I look at, I want to take the factors of the front, or back, divided by the factors of the front. So what are the divisors of 1? Just plus or minus 1. What are the divisors of 2? Plus or minus 1, plus or minus 2. So what am I going to do? I'm going to take plus or minus 1 divided by plus or minus 1. That takes care of this guy. Then I'll take the numerator's just plus or minus 1 and divide it by the second factor in the denominator, plus or minus 2. To recreate my list, plus or minus 1 divided by plus or minus 1 is just plus or minus 1. Plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. I have 4 plus or minus 1 plus or minus 1/2. I have 4 rationals. I've got a degree 5 that has max 5. I found 4 possibilities. Not all 4 of them will work because they could be irrational or they could be imaginary. So I can have rational roots, I could have irrational roots, or I can have imaginary roots, or a combination of all 3. But some of these or all of these may or may not work. That's the next page. Okay, let's make our list. The front is 6. The back is 2. Remember, we're going to take the factors of the back divided by the factors of the front. That creates my list. The back is 2. So the divisors of 2 are plus or minus 1 and plus or minus 2. The divisors of the front are 1, 2, 3. 4 does not divide 6. 5 does not divide 6. But 6 divides 6. So I start at 1 and work my way through. 1, 2, 3, until I run out. Now, create my list. I start by taking plus or minus 1 into the numerator. So it's plus or minus 1 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 1. By the way, this step you end up doing in your head after a while. Now I've done plus or minus 1. I need to do plus or minus 2. Plus or minus 2 into plus or minus 1. Plus or minus 2 into plus or minus 2. Now divide plus or minus 3 into the numerator. You'll get plus or minus 1 divided by plus or minus 3. Plus or minus 2 divided by plus or minus 3. Now I'm running out of space. I should have moved this guy over. And then I've taken care of plus or minus 3. The next one is plus or minus 6. Plus or minus 1 divided by plus or minus 6. Plus or minus 2 divided by plus or minus 6. That's the complete list. Now I start doing reduced form. Plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 2 divided by plus or minus 2, plus or minus 1, is just plus or minus 2. Plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. Plus or minus 2 divided by plus or minus 2, that's just plus or minus 1. That's already in my list. Plus or minus 1 divided by plus or minus 3 is plus or minus 1/3. Plus or minus 2 divided by plus or minus 3 is plus or minus 2/3. Plus or minus 1 divided by plus or minus 6 is plus or minus 1/6. Plus or minus 2 divided by plus or minus 6 is plus or minus 2/6. Plus or minus 2/6 is plus or minus 1/3. Is that already in my list? Yeah. So, these are the possible rational zeros, of which I have a maximum of what?
4.
4. 2, 4, 6, 8, 10, 12. I've got 12 possibilities, but I only need 4 of the 12 or fewer. Because if I end up with things like the irrational or imaginary, that cuts down on the number of real zeros I'm going to have. Or rational ones, actually.